So in the last video, we discussed about the first and second lab assignment. So in this video, we will discuss about the third lab assignment, that is design a Verilog HDL to implement binary adder, subtractor, half and full adder, half and full subtractor. You can see the table of half adder design. We have two inputs here, A and B, and the inputs of A are 0, 0, 1, 1, inputs of B are 0, 1, 0, 1. So we have the input 0, 0 and we get the sum of 0 and the carry out will be 0. We have the input 0, 1, so the sum is 1 and the carry out is 0. And we also have the inputs 1, 0. We have sum 1 and carry out is 0. The inputs are 1, 1, the sum is 0 and the carry out will be 1. So you can also see the circuit diagram of half adder design. By seeing the table, we can write the sum expression, that is A bar B plus AB bar, and the carry out expression will be AB. Now we'll see the full adder design. So we have 8 inputs here, that is 0, 0, 0, 0, 1, 1, 1, 1 of A, and B inputs are 0, 0, 1, 1, 0, 0, 1, 1. And we have an extra input carry in, that is C in. Here we have inputs as 0, 1, 0, 1, 0, 1, 0, 1. Now let's see the sum and carry out of half adder design. So when we have A0, B0, C in as 0, we get the sum as 0 and carry out will be 0. So when we have the A0, B equals 0, carry in is 1. So we have the sum 1 and carry out will be 0. So if we have the A value 0, B value 1, carry in value is 0, we have the sum 1, carry out 0. So if we have A values 1, B value 0, C in is 1, we have the sum 0, carry out is 1. If we have A value 1, B value 0, carry in is 0, we have the sum value 1. So according to the inputs, we have the values of sum and carry out. So you can also see the circuit diagram of full adder design. So full adder design, by its table, we can see the C out K map, that is carry out K map. We have in third position 1, fifth position 1, seventh position 1, and also sixth position is also 1. So we can describe the carry out equation as AC in, AB, BC in, and the sum equals to A XOR B XOR C. So now let's see the full subtractor. Here also we have 3 inputs, that is X, Y, and borrowing, and the various values will be changing according to its, same as the full adder design. The inputs of A are 0, 0, 0, 1, 1, 1, 1. Inputs of B 0, 0, 1, 1, as same as the full adder. You can also see the full subtractor circuit. Here a small difference. Here we doesn't have C in, we have B in, that is borrow in, whereas in the full adder we had carry in, but in full subtractor we have borrow in. Now we can see K map here for full subtractor. We have ones in second position, third and first, and also in 7th position. So the expression for borrow out is YB in plus X bar B in plus X bar Y, and the difference is X XOR Y XOR B in. So now let's see the code for the obtained expression from C out and B out, and also from sum and difference. The Verilog program for half adder and subtractor Verilog code is module half adder or subtractor, inputs A, B, C, A, B, sum, C out, difference, borrow out. Input A and B. Output sum, C out, difference, borrow out. So this is a data flow program. So you can see here a keyword assign. Assign sum equals A or B. Assign C out equals A and B. Assign different equals A or B. Assign B out equals not A and B. End module. So you can see the output here where A value is 1, B value is 1, the sum is 0, and carry out is 1, difference is 0, and borrow out is 0. You can also see the lines, that is thin and thick lines in the output. Now you can see the Verilog code for full adder and subtractor. So we have the code here, whereas a slight change, that is not half, that is full, module, full, adder or subtractor, A, B, C in, B in, sum, C out, difference, B out. Inputs are A, B, C in and B in. Outputs sum, C out, difference, B out. So this is also a data flow program. You can see a keyword assign here. So assign sum equals A or B or C in. Assign C out equals A and B or A and C in or B and C in. Assign difference equals A or B in. Assign B out equals not A and B or not A and B in or B and B in. End module. So for this code, you can see the output here. A equals 1, B value is also 1, C value is also 1, and the sum is 1, whereas carry out is 1, difference is 1, borrow out is also 1. You can also observe the thin and thick line differences here. So here ends the 5th lab assignment. So here the 4th lab assignment, that is design a 4-bit full adder and subtractor and simulate the same using basic gates. So here you see, here we discuss about the 4-bit binary adder or subtractor. Now with the help of single circuit, we are going to perform 2 binary operations such as addition and subtraction. Here we have 2 binary numbers, that is A and B, where each number contains 4 bits. They are A3, A2, A1 and A0, where A3 is the most significant bit, whereas A0 is the least significant bit. Likewise, the second binary number also contains 4 bits, B3, B2, B1 and B0. B3 is the most significant bit and B0 is the least significant bit. With the help of full adder, we can perform addition on 3 bits, that is binary number A bit, binary number B bit, binary number carry. Here M stands for mode control bit. If M value is 0, we perform adder. If M value is 1, it performs a subtractor. Now you can see a Verilog code for the 4-bit full adder and subtractor. We have a structural program here. As I explained in the last assignments, we have 3 types of Verilog programs, that is structural, behavior and data flow. Here you see it's a structural because we have included the wires and the full adder designs and also assign. It's the combination of all 3 codes. So let's see the Verilog module code. Module adder subtractor 4-bit A, B, carry out, sum, borrow out, difference. Inputs are 3 is to 0 A, inputs 3 is to 0 B. Output is carry out, borrow out, output 3 is to 0 sum, output 3 is to 0 difference. So here in the diagram you can see the wire is C1, C2, C3, C4 and the wire C1, C2, C3, B1, B2, B3, B4. C is for carry, that is addition, and B is for borrow, that is subtraction. So you can see full adder of F1, A0, B0, C0, sum of 0, C1. Full adder of F2, A1, B1, C1, sum of 1 and C2. full adder of F3, that is A2, B2, C2, sum of 2 and C3. Full adder of F4, that is A3, B3, C3, sum of 3, C4. Assign carry out equals C4, full subtractor. Now full adder is over. Now we'll go for full subtractor. Full subtractor of F5 of A of 0, B of 0 and C0, difference of 0, B1. Full subtractor of F6, A of 1, B of 1, B1, difference of 1, B2. Full subtractor of F7, A of 2, B of 2, B2, difference to B3. Full subtractor of F8, A of 3, B of 3, B3, difference of 3, B4. Assign borrow out equals B4. End module. So here it's still not ended. Module full adder. This is for the separate conclusions. So A, B, C, sum, carry out. Input A, B, C, output sum, carry out. So full adder, assign sum equals A or B or C. Assign carry out equals A and B or A and C or B and C. End module. Module full subtractor, A, B, C, difference borrowed. Input A, B, C, output difference borrowed. Full subtractor, assign difference equals A or B or C. Assign borrowed equals not A and B or not A and C and B or B and C. End module. So you can see the outputs here. A, that is 3:0, the value of A is 0, 1, 1, 1. B, 3:0 and the value of B is 0, 1, 1, 0, 1, 0 and the carry out is 1. And sum of 3:0 is 0, 0, 1. Borrow out is 1. Difference of 3:0 is 1, 1, 0, 1. So here ends